Charge is a physical property of matter. Current is the rate of flow of charge, and potential difference or voltage is the amount of energy per unit charge. But enough of the definitions, let's look at the equations and look at some examples. In my last video I looked at what charge, current and potential difference or voltage actually are. I'll leave a link to that in the description, and there's probably something appearing on the screen somewhere around me. We'll start with the equation for current, but before I do, let's just check we know the symbols. Q is a symbol for charge. That's because it used to be called the electrical quantity. I is a symbol of current. That's because that used to be called the electrical intensity. And V is a symbol for voltage or potential difference. It's really important that they're all capital letters. That stops us getting them confused with other quantities. As well as having symbols, each one of these quantities or variables each has a unit. The unit for charge is the coulomb, which has the symbol capital C. The unit for current is the ampere or amp, which has the symbol capital A. And the unit for voltage or potential difference is the volt, symbol capital V. All these units are named after famous physicists or mathematicians. I've mentioned potential difference and voltage. They are the same thing really. You won't get marks down for using either term. For this video I'm going to use the term voltage, I think, to keep it simple. Current, I, is the amount of charge, Q, flowing past a particular point per second. To find the current, we get the total charge and divide it by the total time. Notice here that the time has the symbol little t. Here's an example. What current is showing on an ammeter when 4 coulombs of charge pass through the ammeter in 20 seconds? Well, we get the total charge, 4, and divide it by the total time, 20. 4 divided by 20 is 1 over 5. That's 1 over 5, 0.2 amps. Now, you may be somebody who likes to use the triangle. If you do, here it is. Here's another quick example. How much charge flows from a battery in 1 minute if there's a current flowing of 0.5 amps? Well, we use the equation Q equals IT. I is 0.5 amps and the time is 1 minute, but we can't use minutes, we have to use seconds. So it's 60 seconds. 0.5 times 60 gives us 30 coulombs. So the voltage is the amount of energy given or taken away from each charge by a component, such as a cell or a lamp. In physics, we sometimes call the change in energy the work done. So you may hear the voltage described as the work done per unit charge. Anyway, here's the equation. V equals delta E over Q. I like to add the Greek letter delta. It tells me there's a change. But don't worry if you don't or it confuses you, just leave it out. Here's an example. What's the voltage of a battery that supplies 10 coulombs of charge with 60 joules of energy? Well, here's the equation. V equals E over Q. The energy is 60 joules and the charge is 10 coulombs. 60 over 10 gives us 6 volts. Before I give you another example, can I just let you know about my website where you'll find lots more free resources, as well as information about one-to-one lessons with me if you want help with your physics, or even revision courses again with me. I'd also appreciate it if you could like and subscribe, because it really does help the channel, and I love to read your comments and suggestions, so do put something in. So here's another example. What's the energy supplied to a 12-volt lamp by 20 coulombs of charge, assuming that the lamp, of course, is working at 12 volts? Here's the triangle. You could use that, or you could use your math skills to get E equals VQ. The voltage is 12 volt. The charge is 20 coulombs. 12 times 20 gives us 240 joules. Once you've hit like and subscribe, maybe you could watch this.